Hello students, welcome to K-Tech High School and Junior College. Today we shall begin a new lesson, chapter number 10, Space Mission from Science 1. Let's begin. Introduction. Man has always been curious about unknown places and he has always been eager to expand the horizon of his knowledge by exploring the unknown world. He has the curiosity not only about to know the things in the earth but around the earth also. He must have had deep curiosity about the space and the many twinkling stars in the dark sky. He must have had dreams to fly to space and must have been working for that. In this chapter, we are going to learn about the space exploration by man to quench his thirst for his knowledge. So let's begin. The portion of the Earth's atmosphere and the portion beyond that, which can be seen in the form of a roof by our eyes while standing on the earth, is called the sky. The continuous empty space between the spheres in the sky is called space. So children, just look at this. This is the space where we have our stars and our solar system is also present in the space where the sun is present with the 8 planets and their satellites, a dwarf planet, comets and asteroids. Do you remember what is meant by satellite? The celestial bodies that revolve around a planet without independently revolving around the sun are called satellites. Moon is the only natural satellite of the Earth. Space mission. Let's understand it. Substantial developments in technology, especially space technology, in the later half of 20th century resulted in the development of spacecraft making space voyage possible. Since then, more than 1,000 artificial satellites have been placed into orbits around the Earth. Additionally, space missions have been undertaken for close observation of various objects in our solar system. We will learn about all this in this chapter. We can classify the space missions into 2 categories. In one type of missions, the objective is to put artificial satellites in orbits around the Earth for research and various other useful applications. The objective of the second type of mission is to send the spacecraft to outer space for close observation and understanding of the objects in the solar system or even outside the solar system. Need and importance of space missions. The world has become a global village due to space missions. Today, we can contact a person in any part of the world within a second. we can gather information about worldwide events sitting at home, isn't it? You all know the importance of internet. Due to internet, every information is available at our fingertips. It has become possible to get advance alert about natural calamities and take proper precautions. During war, it is possible to get information about the actions of the enemy through aerial surveillance using satellites. It is possible to explore the fossil reserves and minerals in the earth. Thus, there are unlimited applications of space missions. Today, space technology is an inevitable part of our developing of our nation. Now let's learn artificial satellite. In our previous standards, we have learnt about artificial satellite, an astronomical object orbiting the Earth or any other planet is called a natural satellite. The moon is only natural satellite of the Earth. Some other planets in our solar system have more than one natural satellite. Similarly, if a man-made object revolving around the Earth or any other planet in a fixed orbit is called an artificial satellite. The first artificial satellite, Sputnik, was sent to space by Soviet Union in 1957. Today, more than 1,000 satellites are orbiting the Earth. The satellite works on solar energy. So, solar photovoltaic panels are attached on both the sides of these satellites like wings. Instruments are installed in the satellite to receive and transmit signals from the Earth and to the Earth. The satellite has various other types of instruments depending on their functions. One such satellite is shown here. Signals transmitted from the Earth to the satellite and from the satellite to a mobile tower and mobile phone are shown here. These satellites are sent into the space to perform various functions. Depending on their function, satellites are classified into the following categories. First, INSAT, Indian National Satellite. GSAT, Geosynchronous Satellite. IRNSS, Indian Regional Navigation Satellite System. IRS, Indian Remote Sensing Satellite. GSLV, Geosynchronous Satellite Launch Vehicle. And PSLV, Polar Satellite Launch Vehicle. Now, let us study the types of satellite, their functions, and the names of Indian satellite series and their launch vehicles. First, weather satellite. Studies and gives prediction of weather. It belongs to series INSAT and GSAT, and the launcher is GSLV. Communication satellite establish communication between different locations in the world through use of specific waves. So the series is INSAT and GSAT, and it is launched by GSLV. Next we have broadcast satellite. Telecasting of television program is done with the help of broadcast satellites. Its series are INSAT and GSAT, which is launched by GSLV. Next we have the function of navigational satellite is to fix the location of any place on the surface of the earth in terms of its precise latitude and longitude. The series is IRNSS and it is launched by PSLV. Military satellite is used to collect information for security aspects. And the last one, Earth observation satellite. Here, the study of forests, deserts, oceans polarized on the Earth's surface, exploration and management of natural resources, observation and guidance in case of natural calamities like floods and earthquakes. It is done by Earth observation satellite. Its series is IRS and it is launched by PSLV. So understood, children? These are the various types of satellites. Understood? Good. Now let's learn about orbits of artificial satellites. All artificial satellites do not revolve in similar orbits around the Earth. The height of the satellite's orbit from the surface of the Earth, the circular or elliptical nature of the orbit, and whether the orbit shall be parallel to the equator or making some angle with it. All these depend upon the functions of the satellite. The satellite is taken to that height using a satellite launcher. Then the satellite is given a specific velocity known as critical velocity in a tangential direction to the orbit. That is VC. It is in the tangential direction to the orbit. The satellite then starts revolving around the Earth. How can the critical velocity be determined? Let's see. Now, if the mass of the satellite is m and the height of the orbit of satellite is h, speed of the satellite is VE and centripetal force acting on the satellite is equals to mv square upon r. Orbital radius of the satellite from the center of the Earth is r. This centripetal force is provided by the gravity of Earth. Therefore, centripetal force is equals to gravitational force between the Earth and the satellite. So, mvc square upon r plus h is equal to capital G into capital M into small m upon r plus h the whole square. Therefore, VC square is equals to capital G into capital M upon R plus H. Therefore, VC is equals to square root of capital G into capital M upon R plus H. Let this be equation 1. Here, capital G is equals to gravitational constant, which is equals to 6.67 into 10 raised to minus 11 nm square per kg square. M is equals to mass of the earth, that is 6 into 10 raised to 24 kg. R is the radius of the earth, which is 6.4 into 10 raised to 6 meters, which is equal to 6,400 kilometers. H is the height of the satellite above the Earth's surface. R plus H is equals to radius of the orbit of satellite. Understood, children? Let's move ahead now. As the height of the satellite's orbit from the Earth's surface increases, the critical velocity decreases. Depending on the height of the satellite's orbit above the Earth's surface, the orbit of the satellites are classified into 3 categories. Let us learn each one of them. First, high Earth orbits. Height from the Earth's surface is greater than 35,780 kilometers. If the height of the satellite's orbit above the Earth's surface is greater than or equal to 35,780 kilometers, the orbit is called high Earth orbit. A satellite revolving in an orbit 35,780 kilometers above the Earth's surface will take around 24 hours to complete one revolution. We know that the Earth also takes almost 24 hours for one revolution. If the satellite is revolving in an orbit parallel to the equator, the time of revolution for the Earth around itself and that for the satellite to revolve around the Earth being the same, the satellite will appear to be stationary with respect to Earth. For example, a passenger in one vehicle, another vehicle moving parallel to him with equal velocity appears to be stationary. Right? This is also happening here. These satellites are therefore called geosynchronous satellites. Since these satellites are stationary with reference to the Earth, they can observe a specific portion of the Earth continuously. Therefore, they are used in applications like meteorology and for carrying signals for telephones, televisions, radios, etc. The second one, medium Earth orbit. Height above the Earth's surface 2000 kilometers to 35,780 kilometers. If the height of the satellite's orbit above the Earth's surface is between 2000 kilometers and 35,780 kilometers, the orbits are called medium Earth orbits. The geostationary satellites orbit above the equator. These are not only useful in the study of polar region. For this purpose, elliptical medium Earth orbit passing over the polar region are used. The satellites in the polar orbit complete one revolution in 2 to 24 hours. Some of these satellites revolve in circular orbit at a height around 20,200 kilometers above the Earth's surface. Global positioning satellites revolve in such orbits. The next one is low Earth's orbit. Height above the Earth's surface is 180 kilometers to 2000 kilometers. If the height of the satellite orbit above the Earth's surface is between 180 kilometers and 2000 kilometers, the orbits are called low Earth's orbit. The satellite used for scientific experiment and atmospheric studies revolve in low Earth's orbit. Depending on the height of the orbit, they complete one revolution in 90 minutes. International space stations and Hubble telescope also revolve in low Earth's orbit. Understood?